finish up section 9.3. So we left off making a plan for exercise 30 and 31. Can somebody tell me, you're going to have to speak clearly, can somebody tell me how did we make a plan for number 30? How did we get that plan? Yeah, so we were thinking of all students take calculus. We noticed that it says cosine of theta is equal to something positive. And so we just asked ourselves, well, where are all of my cosine values positive? And that's the same thing as asking where are all of my x values positive. Same thing with number 31, only we were looking at sine values in this case that were positive. All right, so now let's talk about how do I go about following the directions. How do I find, we found that we're going to be in two different quadrants, so I have at least two different answers. How am I going to find my two different answers for theta? Theta is an angle, so I'm looking for an angle. And remember that we're working in this case in degree mode, okay? Because the directions say we're working in degree mode. So the one phrase that I want you to take away for today, we'll use this phrase pretty regularly in the rest of chapter 9 as well as in chapter 10. I can't remember if we choose it in chapter 11, but I know we use it in 9 and 10. And the phrase that I want you to really grab a hold of is that inverses, okay, that's an R, inverses find angles. Inverses finds angles. If you want to find an angle that's not on your memorized unit circle, I mean, come on. If it's on your memorized unit circle, all you're going to do is pull out your unit circle and you're going to figure out what angle it is. Okay? But if you're working on something that's not memorized, like the ugly decimals that we've been given to work with here, then what you're going to do is you're going to use the inverse button. Okay? So you have your calculator. Make sure it's in degree mode. And I forgot to get batteries for my calculator. Oh, I brought a spare. And it has batteries. I'm doing well. So make sure that you're in degree mode, okay? And I'm not going to go too far with this. Don't start typing things yet, okay, other than maybe the on button. But if I want to find theta, okay, and that is my goal here, is to find theta, then what I'm going to type in is the cosine inverse of this ugly 0.9647 yada, yada, yada. Okay? Now, again, some of you are going ahead of me, and you're not going to listen to what I have to say, and then you're going to get it wrong, and I'm not going to feel sorry for you. The idea here, folks, is that this is only going to give you one answer. You know you have to have at least two answers. It will not give you all of your answers, okay? So later on in chapter something, I don't remember if it's 9 or 10, we're going to discover why the calculator only gives certain answers, okay? And so we'll learn about that. We're not quite ready for that. So for now, just believe me in knowing it's not going to give you all the answers, okay? It's only going to give you one of your correct answers. So go ahead. Let's type this into our calculator. You don't have to type the theta equals part. Just type in cosine inverse. Where do you find cosine inverse, folks? Yeah, it's that second cosine. And here you should get a theta value that is 15.2557. Did you guys get that? Okay. And by the way, why did I round the way I did? Robert's rounding rules. Now, which in our plan, which answer did we find? So I just didn't understand.
first quadrant?
Yeah, the first quadrant angle. We found the first quadrant angle. We still have to find the fourth quadrant angle, okay? All right, can you do me a favor, which I shouldn't have to ask you to do this. Pull out your unit circle or look at your unit circle. And what I want you to do is I want you to go one slice up and one slice down. So that would be at a pi over 6 and a negative pi over 6. One slice up, one slice down. What's true about the x values, one slice up and one slice down? There's more than that. They're exactly the same. They're exactly the same, okay? Why? Because of the fact that my x value is not changing to go one slice up and one slice down. It's my y value that's changing, okay? My x value is unchanging. So now wait a second. So what were those two angles again that I just had you look at? What was the one in the first quadrant? On the unit circle, the one I just had you look at. Pi over 6, or 30 degrees, because I didn't tell you if we were talking about radians or degrees. And what was the one slice down called? Yeah, negative of the same thing, right? You had a positive pi over 6 and a negative pi over 6. A positive 30 and a negative 30. Why? Because those have the exact same x value. Okay, so now let's apply that knowledge to what we're looking at. Okay, I need a fourth quadrant angle and their cosine values, their x values, are the same. My x values are unchanging. So if I had to go up 15 degrees, what am I going to do to get my fourth quadrant angle? Go down 15 degrees, and the name of that would be called, don't think too hard, I'm just looking for a number here. Negative 15 something, right? Okay, and that would be correct, but does that follow the instructions? Is negative 15 degrees inside of that interval? No. So I can't call it negative 15 degrees, even if that's a correct answer, because it doesn't match my instructions. Okay, so then how do I get that fourth quadrant angle? How do I get the angle? Here's a great review word for you. That is coterminal to negative 15 degrees. You're going to subtract 360? You're going to add 360. I just add a whole circle. Add a whole circle and get back where you want. Okay, so you've got the 15-degree angle still sitting on your calculator screen. Just do plus 360. What'd you get? I beat you. Nobody said anything, so I won. Okay, so I haven't written my answers nicely, so let's go ahead and do that. By the way, does 375, okay, it's always good to be thinking, does this make sense? That didn't make sense. It's not between 0 and 360. What did I do? What did I tell you to do that was incorrect? We added 360 to the first quadrant angle. We got our coterminal angle to the first quadrant angle. Right? We didn't want an angle coterminal to the first quadrant angle. That's our bad. My bad. Okay? So we wanted it to the fourth quadrant angle. I had the positive 15 sitting on my screen. So did you. All right, even though we were talking about the negative 15. All right, so just go back and get that negative 15. You can do 360 minus that answer. That's the same thing as doing the negative 15 plus the whole circle, 360. All right, so I have negative 15 blah blah plus 360. Okay, now what does that give me? 0.74. So this is a great time to talk about, first of all, I told you before, it's okay to make mistakes. You've seen me make mistakes on multiple occasions. That was a pretty bad mistake. But always have little plans in place to be asking yourself, does my answer meet all the requirements? As soon as I wrote that down, I was like, wait a second, that's not between 0 and 360. Okay, so make sure that you're always keeping the instructions in mind. Don't just write down an answer and leave it forever. Be thinking about whether or not it makes sense. Again, it's okay to make those mistakes, but have plans in place that will catch your mistakes. So then my two solutions there, one is the 344 and the other is the 15, okay? Now let's go talk about the next one. So I've already come up with a plan, okay? How am I going to find an angle here? Yeah, inverses find angles. So what we're gonna do is we're gonna say, well, my theta has to equal sine inverse of this 0.63 number. Okay, so the directions are unchanged. So let's go ahead and type that in. And which quadrant answer were you handed? You were handed the first quadrant angle. What did you find for your first quadrant angle? Yep, that's what I got as well. 39.7162 degrees. See, our plan is different here. Like I couldn't answer with a 39 and a negative 39, right? Okay, so I want you to look at your unit circle for a minute. Let's try to look at something we're familiar with or we're getting familiar with and try to apply it to something we're unfamiliar with. When you're looking at your unit circle, now remember sine is related to which value? Y values. Can you look into the first and second quadrant, because that's what's in our plan? Look in the first and second quadrant. Do you see any y values that are the same? Where? Go ahead, Jade.
5/6 and then 5/6 and also with the 5/3 and the 2/3.
Okay, so then let's stick with only one pair of that. Let's stick, Jade, with the 5/6 and the 5/6 pair. Okay? Now, do you remember how when I was doing the cosine question, I said they were both one slice away from the x-axis, right? Up a slice, down a slice. Is there something kind of similar that you could use to describe the 5/6 and the 5/6? One slice away from the y-axis? Which one? Yeah, the x-axis. Now, it's not the same x-axis, right? One of them is over on the left side and one of them is over on the right side. By the way, you know what we're starting around right here? All of these are dealing with reference angles. Okay? All of these are dealing with reference angles. Remember, reference angles are how far away are you from the x-axis? These two were the same distance away from the x-axis. Okay? But quite frankly, these guys are as well, just on opposite ends. Okay? If I'm going up from the x-axis 39 degrees, I also have to go up from the x-axis 39 degrees. Just like on those, the pi/6 is going to go up one slice. Actually, it's over here for you guys, right? The pi/6, I got myself backwards. Yeah, it's over here for you guys. The pi/6 is up one slice, and the 5/6 is up one slice, right? So same thing here. 39 degrees is up 39 degrees. Let's go up 39 degrees from over here. So what kind of math then do I have to do to get that second quadrant angle?
What we got? First quadrant,
Yeah, so we want to do 180 minus that 39-degree angle, okay? So my second theta will be 180 minus the 39. And you should get 140.2838. Now, I gotta tell you, I don't have memorized a process here. Like my brain doesn't say, okay, if you're dealing with cosines, then you need to make sure that you do 360 minus your angle. But if you're dealing with sines, you need to make sure you do 180 minus your angle. I'm gonna forget that stuff, that's too confusing. Because tangent's even different. Okay, so it's much easier, in my opinion, it's much easier to come up with a visual plan. And when you're looking at your picture, you can tell, oh, there's 360, I gotta take away that. I gotta take 360 away from that first quadrant angle. Or, oh, this is just going up from 0 and also up from 180. Okay, so it's easier if you have a visual plan. I'm gonna change the next two questions because these are all a little boring. They are positive. I want to work with some negatives. Okay, so both of these then, the next two, I'm gonna say cosine theta is equal to a negative 0 point blah blah, and cosecant is equal to a negative 1. So let's change those on the problems, just so that we can get some extra practice here. If I only did four positives, you're gonna think that we always have positives, and that's not the case. Okay, so talk to me a little bit about how the directions have changed now. It's in radians, okay? Otherwise, the directions are identical. So the only thing that's gonna change here is my my brain has to change over to radian mode and my calculator has to change over to radian mode. Okay, that's the only thing that's going to change. Otherwise, the work is exactly the same. So before we start typing anything, what's the very first thing we want to do on questions like this? We got to come up with a plan. Because if you don't come up with a plan, you might forget some answers. Okay, so how do we ask ourselves about our plan on this question? Say it again. Yeah, where is cosine negative? Second and third quadrant. And this helps me to know, to check my work and make sure that my answers are lining up with what my plan said it was going to be. All right, now that I have a plan, I can go and find one of my angles. I won't be able to find both of them in the calculator, but I can go find one of them. So we'll have theta is equal to cosine inverse of negative 0.7 blah, blah, blah. Okay, what'd you get for that? Oh, don't be nervous. You've already seen me make a mistake and I didn't die. It's okay if you're right or you're wrong. I don't care. What'd you get?
38.49.
Did you remember to switch over to radians?
Oh.
Once you switch over to radians, just do second enter.
2.4698.
Okay. Aaliyah, what'd you get?
I did it wrong.
Okay. All right, so Dylan was brave. Aaliyah was brave. What do we got? Do you guys agree or disagree? Okay. All right, so we have 2.4698. I agree as well. And automatically we remember that radians are kind of the weird guy, right? because I'm asking myself, is that in the second quadrant? But there's a really easy way to find this out, okay? And actually, once I start going through it, you guys are gonna be like, oh, yeah, duh, no problem, okay? Now, don't mess up your calculator screen because we're gonna need it here in a minute, but I'm gonna come down to some scrap paper, and I wanna look at the unit circle in radians, okay? So in radians, we know that this place here is your starting place, 0. And then what about this place? Pi. Now, you guys all know the decimal value of pi. What is it? 3.14. Okay, and then if you take half of pi to get your pi over 2 spot, because that's what it says, pi divided by 2. Pi divided by 2 ends up being like 1.57. Oh. So is my answer of 2.40 something or other, is it in the second quadrant like it was supposed to be? Yeah, as soon as you convert your pi's into decimals, it's pretty easy to check whether or not you're landing in the right quadrant. Okay, all right, so then let's go back to the question. That gave me my second quadrant angle. How am I gonna find my third quadrant angle? Subtract by pi. So that's basically what she's saying, only in the reverse, right? You're saying to subtract from pi. You said subtract by pi. You said subtract from pi, right? So let's pull out our unit circle. Okay. And let's use something familiar to try to come up with a rule for something not familiar. Now, you're looking in the second and the third quadrants. Okay. And you're also looking at which values would we be looking at in this question? Why x values? You're correct, but why? Because it's cosine. Cosine is the x value, right? Okay. So on your unit circle, looking quadrants 2 and 3, can you find x values that are the same? Can you give me a pair? There's more than one pair. Can you give me a pair? Say it again. And at what angles do those occur? 5 pi over 6 and 7 pi over 6. Now, I know that you're going to be tempted to say that they are one slice away from the x-axis, and they are. But I want you to think about how you get to 5 pi over 6. How do you get to 5 pi over 6? Where do you begin to get to 5 pi over 6? Where do you always begin, right? You always begin here. So in order to get to 5 pi over 6, you got to start here and you got to go all the way around to about right here, right? Okay, cosine values are which values? The x values. Also, think back to the last one. What did we do on the cosine problem to get our second angle? The last time we did a cosine inverse, what did we do to get our second angle? Yeah, we did the whole circle minus our original, because remember it was a positive 15 and a negative 15? Oh, maybe this should be a trigger. Yeah, that's 5 pi over 6. What is this side? Negative 5 pi over 6, right? Okay, so then in that case, what kind of math should I do to get my third quadrant angle? Subtract. Okay, Leah says that we should be subtracting 360 minus the given angle. You guys agree with her? 2 pi. Why 2 pi? We're working in radians. We're working in radians. Yeah, so you're gonna do 2 pi minus that 2.4 number. And so my second theta should be 3.8134. And let's go back to this concept right here. If you take, what is the value here in radians? 3 pi over 2. If you convert that over to a decimal, that's going to be 4.71. Can you do 2 pi in your head? The decimal value of 2 pi? Yeah, it's 6.28. So then our answer of 3.8, does it land in third quadrant? Yeah, it does. Okay, so now, so you say, but Ms. Roberts, I still feel like my idea was pretty good where I'm just going to add to pi or take away from pi. Okay, and let me talk to you about why that doesn't work. It's a little easier to think of this okay. I'm trying to think about the best way to describe it. On this question, we basically looked at that value and we looked at this value. Agreed? Okay. You knew that this angle was that 2.4 number. Okay. You did not know from here to here. Now you could have found it, but like we talked about it being one slice away. We could tell it was one slice from the x-axis when looking at our own unit circle. But we didn't know how far this was. It would be pi minus whatever that 2 number is. Okay, and so we would have had to find this little guy to be able to say, all right, now let's add that same little guy to pi. Does that make sense? Okay, and we didn't know that value. It could be done that way. It just takes a few more steps. Okay, so that's why I discourage you from going through the pi concept as opposed to just looking at this as the distance from 2 pi. Okay, all right, let's do this one. This one by far is the hardest of the 4. Why? You don't have a cosecant button. You don't have a cosecant inverse button. But before we ever start punching buttons, what should we be doing? We need a plan. We need a plan. Okay, so what's our plan gonna be? Y values, because cosecants, partner in crime is sine, and sine is the y values, okay? And so where will we have solutions? Quadrant 3, quadrant 4, where we have negative y values. Okay? Now, so we have a plan. So at least now I know where my answers are gonna land. But now I have to figure out how to work with the calculator since I don't have a cosecant button and I don't have a cosecant inverse button, okay? So step number 1 is not inverses. Step number 1 is rewrite the problem so that I can rewrite it with something that I do have a button for. Rewrite the problem so that I can use one of the buttons on my calculator. Okay, which means how is the only way that cosecant can be rewritten? As 1 over sine. Okay, so a lot of students get lazy on this step. It also costs them, not because I take points off for laziness, but because it ends up, they skip something and it causes them to have a wrong answer. Okay, so let me walk you through what my brain is doing. My brain says that cosecant equals this -1 point number. Do you agree with that? My brain says that the sine is going to equal the reciprocal of that, right? Because sine and cosecant are always reciprocals of each other. So if you have cosecant equals ugly, sine is going to be 1 over that ugly, right? So this is going to be 1 over negative 1.0219, yada, yada, yada. So step number 1, rewrite it with something I have a button for. Now, can I take this even a little further? Because sometimes this starts to confuse students. Because we have 2 different kinds of questions that are very similar that we have that we've dealt with, and so students start getting a little tripped up. So let me do this in case you start getting yourself messed up. Okay. Sometimes, and this is the part that students are lazy on, and so if you're getting wrong answers the way I'm showing you, do it this way. You told me that cosecant is equal to what? 1 over sine. Okay, so another way that I could rewrite this is 1 over sine of theta equals negative 1.02 blah, blah, blah. Would you agree? I replaced cosecant with 1 over sine. And now all I see here is a proportion. And you know that you can cross multiply, right? Okay, and so an easier method than cross multiplying even is that it's totally legal to take both fractions and flip them over. It's the same as cross multiplying, quite frankly. So I'm allowed to take both fractions and flip them over. When you take both fractions and flip them over, what do you get? Don't you get this guy? Sine equals the fraction. Okay, so that's just like a secondary way to explain the same thing in case you're starting to get a little confused about that. Okay, all right. Now, what finds angles? Inverses. So now I'm going to take my calculator, and if I want to find theta, I'm going to type in sine inverse of a fraction, 1 over negative 1.02 blah, blah. Whoa. What were you given? You were given an error? Wait a second, did you use the minus sign for your negative instead of using the negative sign for your negative? I mean, you and I know that they're the same thing, but for whatever reason your calculator thinks they're different. So the negative down at the bottom by the enter button instead of the minus sign. You didn't do 1 divide. Okay, you didn't rewrite what I wrote. And you're not typing in what I wrote. Do you see what I'm saying? Yeah. So it should be 1 divided by. Sine inverse of 1 divided by. That was the problem. Okay. Are we all good? What'd you get? It was weird. You got a negative number, didn't you? So my theta here is equal to negative 1.3631. So Dylan, don't be lazy. Write down the theta equals. That will make a difference. Okay. Okay. Now, in which quadrant is negative 1.36 radians? It's in the 4th quadrant, right? In the negative direction on the 4th quadrant. Because, again, think about our decimals. 1.36 is in the 1st quadrant. Since it's negative, we're going into the 1st quadrant down, right? Okay, so I've got my 4th quadrant answer, but does my 4th quadrant answer satisfy my restriction? No, because my restriction is all positive numbers, right? So it doesn't satisfy my restriction. So what I need to do 2 things. first of all, I need to find a good fourth quadrant answer. Okay. And secondly, I need to find a good third quadrant answer. So again, think about the fact that we're working with signs, and signs are which values? Y values. So I'm really only thinking ups and downs here. So this guy is down 1.36, agreed? Which also means this guy is down 1.36. Okay, so then walk me through, how can I find my third quadrant angle? So if you do pi, what's that? There you go. Why'd you change your mind? Where would pi minus have landed you? In the second quadrant, but you want to be in the third quadrant. So he's exactly correct. I want to do pi plus my 136 number. Okay, and by the way, it needs to be a positive 136, a pi plus a positive 136. Don't do anything yet, don't do anything yet. Okay, just wait, just wait. And then the second thing that I want to do is, okay, I know that I'm going down 136 here, but how am I gonna find this spot? What am I gonna do with 2 pi? So are you gonna do, wait a second, I interrupted. Try again. Yeah, you're going to do 2 pi minus the 136. So you're going to do pi plus the 136 over there, and you're going to do 2 pi minus the 136 over here. Okay? Now, you say, but I don't want to write it, I don't want to type in that whole decimal all over again. Do you guys know how to store numbers in your calculator? So let's learn how to do that really quickly. This will help you out. Okay? It'll give you some shortcuts. So look right above the on button. You see how it says stow? We're going to stow this number. Okay? Now, the thing is since I'm mostly going to be working with the positive, I also want to change it to a positive. Okay? So here's how I'm going to do it. Go ahead and push the button stow. And right now it says answer, and there's an arrow. Okay? Okay, so right now I'm just storing it as the negative. It's fine, we'll work with the negative. And so we have to name it. The calculator's waiting for us to name it. Do you see how you have letters on your screen or on your keyboard? Name it with a letter, okay? So if you want A, you're gonna do alpha A. If you want B, you're gonna do alpha B. You can name it with any letter you want to. So I'm gonna pick alpha A because I'm boring. So when I do answer and I store it as alpha A and I push enter, do you see how it just bumps that same number right back to you? Well, the cool thing is that now whenever I want to use this number, all I have to do is type in alpha A. I don't have to type in that whole string of decimals. Now, let's say that in the next problem, I want to store another one and I still want to use A. All you have to do is store on top of the old A. You don't have to delete anything. Okay, so you can always store on top of the last number if you want to use that same letter again. Okay, all right, so again, remember that our A is negative. So we wanted to do 180 plus the 136. So how can I do that if my A is a negative number? Say it again, 180, sorry, pi, we're in radians, pi minus the A, which will mean minus a negative 1.36. Are you with me? Okay, so go ahead, just do pi minus alpha A. Does it land you in a good quadrant? Yeah, it does. It does. So where did you get that? Zero. Theta is equal to what? 4 point. Did you get 5047? Now that gives us our good third angle. The last thing we have to do is get our good fourth angle. Okay, so again, our plan said we wanted to do 2 pi minus the 136. Wait, was that right? Yeah, 2 pi minus the 136. So how can I use alpha A? I'll type in 2 pi, but then how am I gonna do this? Remembering that my A value is a negative. 2 pi minus, yeah, just do 2 pi plus A. That'll be the same thing as 2 pi plus a negative 1.36. Check it. Does it match the fourth quadrant? Does your number match? Yeah. What did you get for that? 4.9186. I didn't get that. Is that what you guys got? That's what I got. Oh, and your first one was different too. What's the angle, guys? What's angle A? Negative 1.36. Oh, there it is, 3.1. So we did something in here that's wrong. All right, 1.02195553. So one little number throws everything off, doesn't it? Yeah, so that was the issue there. Okay, any questions on that? Okay, so it does take some reasoning through this, and some of it you're showing your work, some of it you're not. Okay, but it really takes a good plan, and then once you have your plan and you have your first angle, you have to think through how am I going to get my other angle. Okay, any questions? Spent a little longer on that than I intended, but I also have some extra time, so. Now, what I want you to do for the next section is I want you to have your unit circle handy, but I want it to be hidden. Have it handy, but hidden. Mostly because I want you to get used to knowing where the values are and coming up with coordinates without depending on the visual unit circle. I really want you getting comfortable with the unit circle and not, yeah, okay. Apparently, I'm having a hard time with my brain communicating to my mouth. All right, so the first question. By the way, the reason that this section goes so quickly is because every bit of it is reviewed. If I remember correctly, there's not one thing that's new in this section, not one. Okay, so some of the questions I'm going to skip because it's all old material. Okay, so there's nothing is new. So really, I could even say at this very moment, I've covered everything I need to cover for the test. Okay, so, all right, so remember how we did these? What did we draw first? We drew a little mini unit circle, right? And what did we mark on our mini unit circle? Say it again, Dylan. Okay, yeah, so you're thinking of when I was looking for theta. I'm not looking for theta because I know my theta. Okay, so you're right, that is what we did on the last 4 questions, but I'm more thinking of going back even further in your brain. What did we do when I knew what the theta was? Where? Find the position, right? Go find 5 pi over 3. So try to do this without looking. Where is 5 pi over 3? Second quadrant? Fourth quadrant. 5 pi over 6 is in the second quadrant. Okay? 5 pi over 3 is the first spoke into the fourth quadrant when you're going in the positive direction. Okay? Now, again, without looking, I want you to be able to recognize longs and shorts so that you can get a good coordinate for that spot. So without looking, what is the coordinate there? 1/2 negative root 3 over 2. Okay, so now I have a coordinate. What's the cosine? Why? Very good, very good. Adjacent to the hypotenuse would be the x value over 1. So it's just going to be the x value. Now, on this set of directions here on your test, it says something like, find the exact value, but it also says, give a short explanation or show your work to receive points. The work that I showed is sufficient. Okay, that's enough. I just want to know that you didn't just stick it into your calculator. And the directions I think also say no calculators, I think. They should, if they don't say that, they should. All right, but I do specifically remember putting in there, show your work or give a short explanation for your answer for points to receive credit or something like that, all right? So, okay, let's look at example 2. So what will we do first? Draw it. Where's 11 pi over 6? Fourth quadrant, where? The very last spoke, right? Right before you get back to 2 pi. Okay, look at your longs and shorts. What's the coordinate? Root 3 over 2 is my x value. What's my y value? Negative 1/2. Okay. Now, how do I figure out the cosecant at that spot? The reciprocal of sine. Okay, so my brain is going to say negative 2 over 1. Why did I choose that one for sine? So y value. Okay, so again, showing a position and a coordinate is enough for me to know that you know what you're doing. That's enough, okay? I mean, you can show more, but it takes time. Oh, this one's weird. I want to show you 2 different ways to do this one. Okay. The first way you could do this is to count all your pi over 3s until you get to 17. Let me show you what I mean. You can just watch, okay, because I'm going to show you an easier way. You can just watch, because here's my 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, right? And I could keep on counting. So here I'm at 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I know that 17 pi over 3 is coterminal to 5 pi over 3. Okay, option number 1. Option number 2, think about the number 17/3. That's an improper fraction. What would it be as a mixed number? 5 2/3? Agreed? Okay. And so when I put pi's back in there, this is the same thing as 5 whole entire pi's with another 2 pi over 3. Okay. Now, where would 5 whole entire pi's be? Let's make this make sense. If this is 0, this is 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Okay, let's make a generic statement. What are all these pi's? These are all even pi's, and these are all odd pi's, right? So this is 5 pi. This is 93 pi. I don't have to count that high, right? All of my odd pi's are on this side. And so if I'm at 5 pi, just go 2 more pi over 3. Well, here's 1 pi over 3, 2 pi over 3. I still land on the same spot. I just didn't have to count around. So, like if you don't have very far to go, 17 is not very far to go. But if I gave you something like 93 pi over 3, that might be a little more challenging to keep counting. We would end up losing our place. Okay, so, all right, so I know then that tangent of 17 pi over 3 is the same thing as tangent of 5 pi over 3. Notice here how I'm showing my work. Because 17 pi over 3 and 5 pi over 3 are coterminal to each other, so therefore they have the same tangent. And what is my, what's my coordinate at 5 pi over 3? Yep. Okay. And how do I find tangent? Opposite over adjacent is one option. What's another option? Sine over cosine, and then there's one more that I've used. Think of letters. Y over x. Okay, any of those is fine to use. All right, so if I have y over x, sine over cosine, that's going to be negative root 3 over 2 over 1/2, which is going to end up being negative root 3. And again, if you're required to show work, this is a sufficient amount of work. I can see that you know what you're doing. Okay? Okay, let's see. I've got cosine. Let me do at least just one of each. So where is negative 4 pi over 3? By the way, now you can unhide your unit circle because we need to move a little bit more quickly. Where is negative 4 pi over 3? Think about where 4 pi over 3 is and how you get there, and then get there the same way in the negative direction. Yeah, it's coterminal to 2 pi over 3. It's coterminal to 2 pi over 3. Okay, what's the coordinate at 2 pi over 3? Good. How will I go about finding secant? Reciprocal of cosine, which is going to be the reciprocal of So like you could say this fraction here is showing you the reciprocal of the x value. Okay, so that's the showing the work part on that. All right, what about number 5? You've got your unit circle in front of you. Okay, where would you find 13 pi over 3? Where? Coterminal to what? What's it coterminal to? Pi over 3. Yeah, so my brain on this one, guys, I like using the mixed numbers. So my brain would have said, hey, 13/3 is the same thing as 4 1/3. 4 whole pies lands you back at the beginning, and then I just add on to that another pi over 3. So that's how my brain does it. You could also count your way around. If you count your way around, you know that this is going to end up being 12 pi over 3. 12/3 is 4 pi. Okay, so if this is 12, you go one more pi over 3 to get there. All right, so coordinate. I beat you. 1/2 root 3 over 2. Now, talk to me about how to find cotangent. What are some different ways that we can look at cotangent? Cosine over sine, x over y, adjacent over opposite, okay? So if we did x over y here, let's see here, I'm gonna write down cotangent of pi over 3. I marked it on the circle, but just to write it down. And so this is going to be x over y, so that's gonna be 1/2 over root 3 over 2, which is root 3 over 3. Once again, I've shown you the work on multiplying by the reciprocal a couple of times, so that's why I didn't show you the work here. I have accidentally memorized that. I've already done a cosine. Let's do, have I done a sine? No, let's do a sine. So where's 5 pi over 4? Middle of the third quadrant. Coordinate. Neg root 2 over 2. Neg root 2 over 2. Sine value. The y value, yep, neg root 2 over 2. Do you see how this is more of the same? So where's 3 pi over 4? I'm not going to do all these, okay? Where's 3 pi over 4? Okay. Coordinate? Yep. And then from there, I can go find all 6 of my trig functions. Okay. Let's go to number 9. Where's my position? Right here, right? Coordinate? -1, 0. Man, we got to take our brains all the way back to section 9.1 for this. What did we do when our coordinate landed on an axis? Oh, we worked with the reference triangle. Do you remember that guy that I drew up on the board? We worked with the reference triangle. Okay, so the reference triangle, x, y, r, and theta. Remember this guy? Okay, so when it was on an axis, this is how we dealt with it. So according to the reference triangle, what is sine on my reference triangle? Y over r. So then we just used our coordinate. What's y over r? What is my r here? 1. So what's y over r? 0 over 1, right? Which is 0. Now while we're standing here, what about cosecant? Undefined, because it would be 1 over 0. You with me? Okay, go to your reference triangle. What's cosine? X over r. So what's x over r going to be? -1 over 1. Flip it over. What's secant going to be? -1. I really, at this point, don't need the reference triangle for tangent, but I can use it. Okay, because what is tangent again? Yeah, it's sine over cosine. So as long as I did the sine and the cosine correctly, I can use what's in my table, or I can use y value over x value from the reference triangle. But what would sine over cosine be? And then cotangent would be undefined. Okay, so that's a good time to review when we used the reference triangle. Do 11, 12, and 13 and compare it with somebody close to you. 11, 12, and 13, compare it with somebody close to you. You can fit all three on your screen. So compare your calculator screen with somebody close to you. See if you got the same thing. Okay, so look at your calculator screen and see how your calculator screen is. Did we check? And did anybody get a chance to check use cases? You guys get the same thing? Okay, answers are on the screen. Did you guys get what I got? What mode should your calculator have been in? How come? There's no degree symbol. There's no degree symbol. So 11, 12, and 13 are easy questions, but the reason that people miss them the most is because they forget about the mode. Okay, so that's what people miss the most on those. They don't do it wrong, they just forget to check the mode. Now, 14, 15, and 16 are a little more challenging because you don't have buttons for these, right? Okay, so how am I going to do number 14? Yeah, this is the same thing as 1 over the sine of 1.3875. This is not the same as the last 4 questions we did in the last section. Okay, here I know my theta. The last section we were looking for theta. So they're different. And here you should get 1.0170. Okay, now do 15 and 16. And check with somebody close by. So much for lab day. Shh. Check with somebody close by. Okay, 15 and 16 answers are on the board. Did you get them? Okay. All right. Number 17, I'm going to change the question. I'm going to make it more of a review from section 9.2. Okay. So the coordinate is negative 15, 8. That's what I'm changing. Negative 15, 8. So we did these back in, it was either 9.1 or 9, I'm pretty sure it was 9.2. That we did these. 9.1? I don't remember. It was in one of those two. 9.1. Okay, and I'm supposed to find the 6 trig functions. Now, I only want you to find sine and cosine. Just sine and cosine. Write those down. Just sine and cosine. Write them down. Okay, what'd you get for sine? 8 what? Or just 8? Juan, why are you getting 8 over 17? And why do you know 17 is your R? How'd you get that? Pythagorean theorem. Remember that sine is only the y value. Sine is only the exact same thing as the y value when it's on the unit circle, when the radius is 1. The radius can't be 1. The radius has to be the longest side in each of our triangles. Okay, so the radius can't be 1 here. It would be way too short. So here's where you would have to find the missing side like we did back in section 9.1. Find that radius. Okay, so my radius then is 17 once you do the Pythagorean theorem. And now once you have a radius of 17, then it's easy to find all the missing pieces. So cosine is negative 15 over 17. Tangent will be, what is it? 8/15, right, with a negative? Y value over the x value, opposite over adjacent. And then the other 3 are pretty easy from there. The reason I wanted to change this question is because you've forgotten what we did in 9.1, right? That's been a few days ago, so you forgot the fact that we had to do the Pythagorean theorem to find our missing hypotenuse. So that's why I did that, just to remind you. Good review. All right, 18, 19, and 20. These are exactly like the ones that we did, the last 4 questions that we did in the last section. Except one thing. What's the one thing that's different? Look at the directions. We're going from 0 to pi over 2 instead of 0 to 2 pi. Okay? When we were going 0 to 2 pi, we came up with the plan, didn't we? Okay? What would have been the plan for number 18 if it was from 0 to 2 pi? Which is? Yeah, my plan would have said 1 and 4, right? Well, now this says only from 0 to pi over 2. So what gets tossed? Quadrant 4 gets tossed. Okay? Go to number 19 and change that to a negative. I know I didn't finish number 18, but I'd rather do number 19. So if this had been in the last section, what would our plan say? It would be quadrant 2 and 4. Okay, I guess I can't change it to a negative, can I? Because if it's quadrant 2 and 4, then we would say there are no solutions to this from 0 to pi over 2. Okay, sorry. Well, that was dumb. Disappointingly. Okay, so now that it says positive, what would our plan be? We would have 1 and 3, but which one of those would we throw out according to this set of directions? Quadrant 3. What finds angles? Inverses find angles. So if I want to find angle S, how am I going to go about doing that before I use inverses? Because do you have a cotangent inverse button? No. So when you don't have the button, what do you have to do first? You got to write it using something you do have a button for first. Okay? So what's another way to write this question using something I have a button for? So tangent of S equals so tangent and cotangent are reciprocals of each other. So if cotangent equals 0.2, tangent equals 1 over 0.2. The plan is the same though. Okay, it's still quadrants 1 and 3 with 3 thrown out. But now I can say, all right, so S is going to equal tangent inverse of the fraction 1 divided by 0.2, etc. And I got 1.2798. You guys get the same thing? Okay, now here's something that I haven't talked about, but this is a really good time to talk about it. What if I were still in section 9.3? And what if my directions said 0 to 2 pi? And so I had to come up with a second solution. How do you get from this guy down to this guy? How far apart are they? They're pi apart. They're directly across the circle from each other. Okay, so think back, because this is going to be on your test. We just talked about it today. For cosine, remember you had to go up and down at the same, right? For sine, you had to go like up and up or down and down. Remember that for sine? Okay, by the way, that's sine and cosecant, cosine and secant. For tangents and cotangents, it's always opposite the circle each other. Okay, always opposite the circle each other. So if I wanted a second solution in the last section, then I would have done this answer and I would have added pi to that. Okay, so I didn't happen to do any tangent or cotangent problems in the last section. Do we have time to at least look at number 20? I've got 3 minutes. I might not be able to finish it, but we can at least come up with a plan. So if I were in 9.3, what would my plan be? If I were in the last section, what would my plan be from 0 to 2 pi? Quadrant 1 and 2. Okay, but now that I'm in section 9.5 and my directions have changed a little bit, what am I throwing out? Quadrant 2. Okay, all right, so I have my plan, but I don't have a cosecant inverse button. So what do I need to do to be able to proceed with inverses? Yeah, so sine S is equal to 1 over 1.02. And so if I want S, my angle, I need sine inverse of 1 over 1.02. feel like this is one of the same decimals that I used in the last section. Pretty sure it is. And just as a review, if we were in the last section, how would I have gotten my second quadrant angle? Yeah, pi minus that number on the screen. Okay, because both of them were up 1.36 from the x-axis. So one of them's, yeah. All right. Okay, any questions? Sorry, there wasn't a lab time. I don't know if you were disappointed about that or not. Spent longer on those first 4 problems than I intended to, but it was good. All right, so I will see you next week. Ready for the test. If you have any questions, you know that you can text me, you know you can email me. I do respond, I promise. Have a good weekend, guys.